Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. Okay, selamat petang Hanan. Waalaikumsalam Najwa. Waalaikumsalam Sam. Waalaikumsalam Fir. Waalaikumsalam Alia. Waalaikumsalam Umi. Waalaikumsalam Diana. Hi Pichong. Hi Shikin. Waalaikumsalam Mai. Good afternoon Jiva. Hi Pichong. Okay. Waalaikumsalam Frizan. Okay, so I hope you guys are ready. Okay, so to start our lecture today, and I know you are exhausted. Okay, so I hope you can give if not 100%, then at least 80%. Okay, so at least you can get something lah. Okay, better than nothing. Alright, so and after you print out the notes, okay, so you can jot down some notes, some important informations in the lecture notes. Okay, so that when you need to do revision later on, so you can just refer the notes, yeah. Okay, so you don't really have to watch the recorded video anymore. Okay, because I'm sure you don't have much time left. Okay, so rather than keep watching the recorded videos, so you can just make full use of the lecture notes. You just refer the lecture notes, okay, to help you with revision. Okay, so now let's begin. Today we are going to discuss 9.3 continuous random variables. Okay, so we are going to try to accomplish only 2 learning outcomes, yeah. Okay, for today, so you don't really have to worry. It's not gonna be long. Okay, so this would be continuous random variable. Okay, we are going to find the probability density function. Okay, so it's still called as PDF. Okay, but then rather than calling probability distribution function, it will be called as probability density function. Hold on, I'm going to share my screen. Okay. All right. Okay, so now this is the learning outcomes that we're going to accomplish. Okay, so we will try to accomplish this too, yeah. Find the PDF. Okay, so let's see a bit of summary. Okay, so for discrete, we had discussed before, so you can see here, and we will discuss further in tutorial class. Okay, so now let's discuss continuous random variable. So again, what is continuous random variable? So it is non-countable. Okay, so if for discrete we do have countable or integers, so the continuous random variable is just the opposite. Okay, and when we talk about the PDF, it's probability density function. So it is represented by small letter f. Okay, it's represented by the small letter f. Okay, and then in order to show that, okay, so now let's see here. Okay, so you may come across this integral symbol. So what does that mean? Okay, so now let's see this. Okay, so a random variable whose values are not countable is called continuous. Okay, so we do have probability density function. Okay, so continuous random variables are theoretical representations of continuous variables such as height, mass, or time. Okay, so a continuous random variable is specified by its probability density function. Yeah? Okay, so again, if we recall discrete random variable, okay, so the PDF is probability distribution function. Probability distribution function, and it's represented by this notation, probability when x equal x. So this is the PDF of discrete. Okay, but when it comes to discontinuous, okay, the PDF is called as probability density. Yeah, so this one distribution for discrete is probability distribution function, but now for continuous it's probability density function, and it's written as small letter f. Okay, and then this function is defined over the range from negative infinity or to positive infinity, which means, okay, this function is defined throughout the number line. Okay, so if the probability density function is given as a positive function for all x, okay, whereby the integral of the function from negative infinity to infinity is equal to 1, then x is known as a continuous random variable. Okay, so here you can see this, okay, in this note. If x is a continuous random variable with PDF, then in order to find the probability of x, okay, from A to B. So it's about finding the area, okay, or finding the integral. Okay, so um, algebraically, this is the integral of fx from A to B. Okay, but geometrically, okay, the integral of fx from A to B is in fact the area enclosed by the curve, okay, the x-axis, the line x equals A and x equals B. So this is basically again, okay, the area, okay, area below, okay, area under the graph. Okay, so this is area under the graph, okay, under the graph fx. Okay, and this is also equal to probability. Okay, so from A to B. Okay, from probability of x from A to B. Okay, and okay, you see here, as probability x equals k is 0, so in this case, there's no, okay, it's not possible for us to get a probability of x equal to a value, because, okay, when we talk about the area, let's say if you have this one straight line, x equal a, so let's say if this is continuous and we need to find probability of x equals a, so it is not even possible. Why? Because, okay, you can see that here this area, it doesn't exist, right? So the area is 0, so we would say, so if the probability is 0, so that means when we look for the probability, so, okay, for continuous and variable, it does not matter the equal sign. If you do have the equal sign or not at all, or even equal sign at A only or equal sign at B only, it does not matter. They simply actually mean the same thing. Okay, so these are all basically the same thing. So this is still the probability of, okay, probability of x, okay, from A to B. Okay, even though you have equal or not, but when it comes to discrete, the equal sign really matters. Okay, so you can see here, unlike discrete distribution, so for this continuous, we don't really need to worry about the equal sign. Okay, so it doesn't matter whether we do have the equal sign or not, so, okay, we can just ignore it. Okay, so now let's say example 1. Okay, a continuous random variable x has probability density function. Okay, so it's given as this PDF. Okay, so we are given this function for x defined from 0, okay, from 1 to 3 only. Okay, from 1 to 3 only. Okay, so now question A says sketch the graph of f and verify. Okay, so verify. So now there are two parts of this question. First, we need to sketch the graph, and second, we need to verify that it satisfies the condition of PDF. So now first, okay, if you notice, this is basically linear function. Okay, so if you try to draw a linear function, okay, so if you draw this one without limits, you will notice that it's going to be a straight line going down. But, okay, because the function is only defined from 1 to 3, so you need to bear in mind that the straight line only exists from 1 to 3. So that means, okay, that is why for graph sketching, you are allowed to use pencil. Because, okay, once you draw this line, okay, you can simply erase the rest of the, okay, you can stop here. So that means for this, right after this line, no more graph here. Okay, no more graph. This one also, right after, okay, after 3, there should be no more graph. Okay, so you need to bear in mind that the linear function only exists from 1 until 3 only. Okay, so we have, okay, sketch the graph, done. Okay, after we are done with the graph sketching, okay, so now how to answer the second part of the question, how to verify that it satisfies the condition of PDF. Okay, because we have only one particular function defined for this region, so if we try to for integrate, okay, so now let's recall the concept of integration. Okay, so I just need to, okay, let's recall a bit before we discuss even further. Okay, topic 1, integration. Okay, so, okay, here. Okay, so now let's recall a bit of basic rules of integration. Okay, so you can, okay, make sure you know all these basic rules. Okay, how to integrate constant function, how to integrate polynomial. Okay, so the power added by 1 divided by the power, okay, the power here. And then if you have a reciprocal 1 over x, so what do you have here? Okay, integrating 1 over x will give you ln x. And then integrating a scalar multiplied by a function, so you just take the scalar out. Okay, then this rule if you have, okay, sum or difference of two functions, then you can simply split into sum or difference of two different integrals. And then here you have polynomial to the power of n. Sorry, this is linear. Okay, the function inside the bracket is linear to the power of n. So again, you can only apply this law if you have linear inside the bracket. This one also, if you have the denominator here linear form, so you will get the ln. Don't forget to divide by the, okay, the derivative of the function. And then this one is exponential function. Okay, where this one is index function. Okay, so you have to know how to integrate functions, yeah. Okay, so you need to, okay, you need to have the prior knowledge of topic 1, yeah. Okay, so which I hope you really do lah. Okay, so now coming back to this, so this is linear function. So how to integrate? So you can just bring the scalar out. Okay, so you bring 1/4 out, and then you just integrate 4 minus x. So the function, okay, the integral will be, okay, so the integration of 4 minus x will give you 4x minus x squared over 2. And please bear in mind that this is definite integral. Okay, what makes a difference between definite and indefinite integral? Okay, it's with the limits, right? If you have limits, okay, so it's called definite integral, okay, because of the limits. Alright, so after we integrate, we put the limits here, and then we do substitution. Okay, now you see, we get 1. So what does this tell us about? So this is basically the area. So the area under the graph between 1 and 3 is 1. So which satisfies the condition for a probability density function. Okay, so let's recall. So for discrete random variable, so how to prove it's a discrete random variable? By showing that the sum of probabilities is 1. But now when it comes to continuous random variable, okay, so how to prove that it is a continuous random variable? By proving the integral, or by proving the area. The total area under the graph should be 1. Okay, so this is what we call as total area under the graph. Graph of fx. Okay, so there is a difference. Okay, the difference between discrete and continuous. Okay, for discrete, it's all about finding the sum you add. But for continuous, it's still about the sum, but sum of area. So in order to find the area, you need to integrate. Okay, and then next, find probability x less than 2. So you see 2 is located here. So how can we find the probability? So it's about finding area, okay, below the graph between 1 and 2. Okay, so now you just integrate the function. You take the scalar 1/4 and you integrate the function. You substitute limits 1, 2, and then you get the area. Okay, so please bear in mind, okay, when it comes to probability in this particular topic, even though we are looking for area, the value will always be, okay, between 0 and 1, yeah, because we are dealing with, okay, probability. So let's say if you try to look for the area, you try to find the area, and suddenly you get a value which is greater than 1. So please double check. That means your answer is wrong. Okay, even though in topic 1, when it comes to area, it can be any value, right? Any positive value, but then not in topic 9, because again, okay, when it comes to continuous random variable, we know that total area must be 1. Okay, so again, for any probabilities you find, you have to get the values to be between 0 and 1. Okay, so the rest, okay, so ada lagi yang baru join. Okay, sorry because my OneNote tadi hilang sekejap. Okay, I know. Waalaikumsalam Ain. Good afternoon Razik. Hi Zahid. Okay, so I hope you can stay with me until the end. Okay, so now let's continue example 2. Okay, so a continuous random variable x has probability density function. Okay, so this is it. And the function is only defined from 0 to 4. So, if we try to draw number line, kalau kita lukis number line, so from 0 to 4, the function is defined. So, this is the function defined, kx cubed. So, what does it mean? That means, for the rest of the number line, bermaksud, okay, pada region kurang daripada kosong, kita tak ada langsung fungsi. Okay, there will be no function at all. Okay, so there will be no function at all. So we just focus on this region lah, 0 to 4. Okay, so now how to find the value of k? So the question says find the value of k. Okay, but again, let's recall, we know that for continuous random variable, the total area has to be 1, right? Okay, so the area under the curve between 0 and 4 must equal 1. So what do? So we are going to integrate this function, kx cubed, okay, with respect to x, okay, from 0 to 4, and we equate to 1. Because again, this is the total area. Okay, so now you can just bring the k out because k is simply a scalar. So you integrate x cubed, you will get x power 4 divided by 4, and then you substitute the limits 4 and 0. So you will get 64k equals 1, then k is 1 over 64. Okay, then after we get the value of k, so we can substitute back into the function. Okay, so this one, kx cubed, it will become k 1 over 64 x cubed. Okay, so now the question says find probability of x from 1 to 3. So you can see 1 to 3. So we need to find the area under the graph from 1 to 3. So it's just about integrating the function from 1 to 3. So again, okay, it's just about the same function. You just integrate using power rule, substitute limits, then you will get this answer. Okay, so these are all very basic function. Okay, so you can simply integrate using power rule. Okay, now when it comes to this question, how to find probability x greater than 2? So if you locate the 2, so you can find the 2 is here. So greater than 2 means, okay, in general, greater than 2 means it will be from 2 going to the right, right? But now because the function only stops at 4, so we just find the, okay, probability of x greater than 2, so which means from 2 to 4 only. Okay, even though, okay, logically, okay, in general, when you find this x greater than 2, it should be the integral of function, okay, integral of function from 2 to infinity. But, okay, because this particular function, okay, the function kx cubed or 1 over 64 x cubed here is defined until 4 only, so we will stop at 4. So rather than integrating your function until infinity, so you just need to integrate from 2 to 4, 1 over 64 x cubed with respect to x. Okay, so this is what you will get. Alright, and again, you just integrate the function. Okay, you just substitute limits, then you will get the answer. Okay, so again, guys, if you have any problems, if you have any question, you just ask in the live chat. Okay, so I can see here the number of viewers 37. Okay, now, yeah, it's supposed to be 98. Okay, some of you are sharing devices while some of you are not watching. Okay, so if your friends are not watching, so make sure they watch the recorded videos. Okay, so now let's see example 3. Continuous random variable x has probability density function. Okay, so now what do? Okay, I'm going to draw a number line here to help us to understand. Okay, this function is defined from 0 to 2. So now let's draw a number line 0, 2. Okay, so 0 until 2. So the function defined is kx plus 1. Okay, now next, the second function is defined from 2 until 3. Okay, so this is 2 until 3. So the function is 2k. Then what happens to the rest? To the rest of the number line. So which means from 3 to infinity, the function is 0. The function doesn't exist. From 0 to negative infinity, the function also 0 lah. So we can say that there is no function defined above 3 and there's no function defined less than 0 lah. Okay, so there's no function defined here. Okay, so now find the value of constant k. So how can we find the value of k? Okay, again by using the concept of probability for this continuous random variable, we know that total area under the function must equal 1, right? So what do? Okay, now in this case, because we have two different functions, which means we are going to find the sum of the areas. Okay, so first we need to integrate lah. Okay, we need to integrate this function. Okay, the first function here, okay, from 0 to 2, and here we need to integrate the second function from 2 to 3, and we equate to 1. Okay, why do we equate to 1? Again, because total area must be 1. Okay. Alright, so now what do? Again, so this is linear function. You just integrate, substitute limit. So here you will have k times 4 minus 0. and then 2k, okay, because 2k is simply a scalar, so we just take it out. So you have 2k times x, and we have limits here, so 3 minus 2. Okay, and then you will notice that this is 4k plus 2k equals 1. So 6k equals 1, then k equals 1 over 6. So this is the value of constant k. Again, how do we obtain the value of constant k? By using the concept of this, integral of function, okay, from negative infinity to infinity is equal to 1. So in this case, because the function only defined for, okay, from 0 to 3, so okay, we modify the integral, so it's from 0 to 3. Okay, the integral of function, okay, from 0 to 3 is equal to 1. But again, okay, because there are two functions defined, so that's why we split into two different integrals as this one. Okay, so these are the two different integrals, yeah. Okay, looking for the area. Okay, so that's the first part of the question. And B, sketch the PDF. So how to sketch the probability density? Okay, because this is linear function, right? Okay, because the highest power of x is 1, and this is constant function. Okay, so after we substitute, okay, we get the value of k, we substitute back. So this would be 1 over 6 times x plus 1, while this is going to be 2 over 6, which is 1 over 3. Okay, so you just draw the linear. So this is the linear going up, and this is the constant 1 over 3. Okay, so you notice that here the linear function only exists from 0 to 2. Here you see from 0 to 2 only, so this is the linear function. Okay, while the 1 over 3 here, okay, which is constant function, this constant function exists from 2 to 3. So you see this is constant function exists from 2 to 3. Okay, from 2 to 3. Okay, so this is our PDF. Okay, so now how to find mode? Okay, again, okay, for discrete random variable, we look for, okay, so you see here from the summary, okay, how to find mode for discrete. So for discrete, we can just refer the table, right? We find x with highest probability. But when it comes to continuous, because we cannot really tell, right, the highest probability, because we don't really have one particular value of x. So what do we do is, okay, we are going to find x with the highest peak. So in order to find the highest peak, so, okay, whether you like it or not, you need to sketch the PDF graph. Okay, so again, in order to find mode for continuous random variable, we need to sketch the PDF graph. Okay, so again, coming back to our example, so we already have the PDF, right? So this is the PDF, yeah, so the y-axis here represents the PDF, okay, fx. So you can see here, okay, for this particular graph, okay, the highest peak is this one, right? So this is the highest peak. Okay, so you can see that the highest peak is located when x is equal to 2. So you can see that mode is, okay, the value of x which has the highest probability. So the value is 2. So that is the mode. Okay, so again, in order to find mode for continuous random variable, you need to sketch the PDF. Okay. Alright, then we need to find probability of x from 1 to 5, 1.5 until 2.5. Okay, but then if you notice, 1.5 is located here. Okay, and 2.5 is located in between 2 and 3. So in this case, it is not possible for us to have only one particular integral. Why? Because you see here, from 1 to 5 until 2.5, okay, the region will cross two different functions. Okay. Okay, so now, okay, the region will cross two different functions. So in this case, in order to find the probability, or in order to find the area below the graph, so we need to split into 2. So it will be from 1.5 until 2 plus with 2 until 2.5. Okay, so which means the first integral will involve this function, the linear function, where the second integral will involve only the constant function. Okay, so you can see here in the solution, okay, so you can see there are two different integrals provided here. Okay, because again, in order to find the probability from 1.5 until 2.5, the region will cross over two different functions. So that's why we do have two different integrals here. And you just integrate as usual, substituting limits, then you will have the probability. Okay? Yeah, so we do have one question here. Okay, so Mai tanya kat sini, graf tu ada markah tak madam? Okay, so sekiranya soalan tu minta awak untuk cari mode, dan the only way untuk cari mode adalah dengan sketching graph, so there is a mark for the graph. Okay, sebab why? In order to find mode, the only way is by sketching graph. So kalau sekiranya soalan tu memang minta mode, nak tak nak memang kena lukis graph, so memang akan ada markah untuk graph tersebut lah. Okay, so I hope this answers your question ya. Okay, ya, memang ada markah untuk graph sekiranya soalan tu memang minta mode. Okay. Alright, okay, so now let's continue. Okay, so for the E part, alright, so find probability X greater than 1.8. So kalau kita perhatikan, where is 1.8 located? So 1.8 is located here. Okay, so this is 1.8 ya. 1.8 is here. This is 1.8. Okay, now the question says find probability X greater than 1.8. So kalau greater than 1.8 means from 1.8 until infinity. But okay, because the function only defined until 3, right? So we are going to stop here lah. Okay, so again, conceptually, okay, greater than 1.8 is basically until infinity. But because there's no function defined after 3, so we just stop at 3 here lah. So now we need to find the probability from 1.8 until 3. But then again, you will notice that, okay, from 1.8 to reach these 3, it will cross over two different functions, right? It will cross the red one here and also the green one here. So we are going to have two different integrals, yeah? So we are going to have two different integrals. Okay, so the solution is, okay, 1.8 until 2. Okay, so we integrate the function 1 over 6 times x plus 1. And we add with 2 to 3 and the function, constant function, 1 over 3. Okay, so you just integrate as usual. Okay, so you will have 1 over 6. Okay, so you will have 1 over 6. Here, x squared over 2 plus x. 1.8 tak. Okay, 2 here plus with 1 over 3. X, 2, 3. Okay, and you will get the value 0.43. Alternatively, or, so this is the, okay, second method. Okay, so rather than having these two integrals, okay, what you can do is you can simply use the complement event. Because why? So probability of x greater than 1.8 is also equivalent to 1 minus probability of x less than 1.8. Because you see, okay, this is the region that we want. So which means this is the region that we don't want, right? This is what we don't want. So which means, because we know total area is going to be 1. So it's going to be total area, which is 1, minus this that we don't want. So what you may do is, so you will have 1 minus probability of x less equal 1.8. So it's just about finding the area below the graph, okay, from 0 until 1.8. And you just integrate, you substitute limit, and you put 1 minus, so you will have the answer to be 0.43. Okay, so these are two different methods that you can use. Either you will have one only integral, or you can split into two different integrals. Okay. Okay, so that is example 3. Okay, now let's discuss on how to find cumulative distribution function. Okay, so how to find cumulative distribution function? Okay, so the probability of a continuous random variable is obtained by integration. So is its cumulative distribution function. Okay, so if x is a continuous random variable with probability density function, fx, where the function defined throughout the number line, then the cumulative distribution function is given by this. So the fx, the capital Fx is equal to probability when x is less equal x, okay? So this is from negative infinity until x, yeah? Okay, so again, how to find cumulative? Okay, again, let's see the difference. Okay, when it comes to discrete random variable, no problem. Okay, when it comes to discrete random variable, to find the cumulative, the CDF, you just find the sum. You find the sum, okay? And now, in order to find the cumulative function for continuous random variable, we are going to integrate. Okay, so you can see here, transform. For discrete random variable, from PDF to CDF, we add. From CDF to PDF, we subtract. Okay, just like how to find cumulative frequency from frequency, right? So you add. Then from cumulative frequency to frequency, you just subtract, right? So this is more or less the same as group data for topic 6. But now when it comes to continuous random variable, okay, it's a bit different, where in order to find CDF from PDF, we need to integrate. And from CDF to PDF, later on, we need to differentiate. Why? Because integration and differentiation, they are simply the opposite of each other. Okay, or we would say differentiation and integration, they complement each other. Alright, so now, okay, how can we find this? Okay, so again, you can see here, fx is in fact given by the area under the curve up to x as indicated, okay, by the shaded region. Okay, so you can see that here the cumulative of probability, okay, negative infinity is 0 because here, okay, you have cumulative frequency, cumulative probability from starting from negative infinity here. So this is negative infinity, right? And this is infinity. So in the beginning, so you can see that the cumulative probability is 0, and throughout the number line, you get the total until infinity. So you know that total area is going to be 1. Okay, and again for continuous, yeah, the equal sign does not really matter. So whether you have equal or not, okay, so it still represent, okay, the FA. And again, same thing here, whether you have equal sign or not, so it doesn't matter, it's simply the FB minus FA. So this is how we find probability from the CDF. Okay, so now, okay, I hope that you can pay a little bit more attention to this example. How can we find CDF from PDF? So x is a continuous random variable with PDF fx equals 1 over 8x, where, okay, the function is defined from 0 to 4. Okay, now I'm going to draw a number line here. So from 0 to 4, the function is defined here. Okay, so now the function is defined as 1 over 8x. So if you ask me, madam, what happened to the rest of the region? So here, this region, the function is 0. For this region also, the function is 0. Okay, so now the question says, find the cumulative distribution function. Okay, what do we do? First thing first, we are going to split this region into three different regions. Why 3? Because you can see that there are two values here, 0 and 4. Okay, so this 0 and 4 will divide the region into 3 different regions. Okay, so we have 1 region, 2 region, and 3 region. Okay. Okay, so now for the first region, okay, so for the first region, so this is the region where x is less than 0, right? Okay, so the cumulative function is going to be the area. The area, okay, from negative infinity until x. Okay, what we are going to do, we are going to put the x here. You are not going to integrate until 0. You are going to integrate until x because we should be obtaining a function. We are not looking for a value. Again, because most students, they find it confusing here. Okay, because again, I need to remind you, the cumulative function of continuous random variable is this. Because we are looking for function, so it's going to be the integral from negative infinity until x of fx. Okay, so it should be until x. Because why? We should be obtaining a function. Yeah, we are not looking for a value. Unless, let's say, if you are looking for like this one, f2, and then here you can integrate from negative infinity until 2. You can integrate the function. Okay, so I hope that you can find this difference. So we are looking for function, so that's why we integrate until x. Okay, so now for the first region, okay, we put the x here. Okay, it has to be in the first region. Okay, so but because you see for the first region here, the function defined here is 0, right? So if you integrate function 0, so you will get 0 lah. Okay, and you can see that this explains why cumulative function will always begin with 0 and it will end with 1. Okay, now next, for the second region. So you see for the second region here, this is the region from 0 to 4. So what we're going to do is we're going to put x here in the second region. So now, okay, I'm going to get rid of this now. So from negative infinity, okay, from negative infinity to reach this x in the second region, so you can see that it crosses two different functions. One is the function 0 and one is the function x over 8. So, okay, that's why we can see two different integrals here, because here it's negative infinity to 0 and then here from 0 to x. Okay, and from negative infinity to 0, we are going to integrate the function 0. Okay, because there's no function involved here. While from 0 to x, we are going to integrate this function 1 over 8x. So again, by integrating, and here we substitute the limit 0 and x, yeah? So you substitute x into x, so you will simply get x. Okay, so basically here you will have 1 over 8 times x squared over 2 minus 0. So by simplifying this, you will get x squared over 16. Okay, and now coming to the next region, okay, the third one. Okay, coming to the third region, so I'm going to get rid of this one first. Okay, third region means, okay, this is the third region. Okay, so the third region here, so we put here third region. So for the region where x greater than 4, so we put the x here. X has to be in the third region. So now in order, okay, to integrate the function from negative infinity until x, you will notice that we will cross three different functions. So that is why we have three different integrals here. First, you integrate negative infinity to 0, and then 0 to 4 here, 0 to 4, and then 4 to, okay, it's supposed to be 4 to x here. It's supposed to be 4 to x, sorry. Okay, I hope you can make amendments here. Okay, if you have printed out the notes, it should be x here. Okay. Yeah, okay, because we are looking for the cumulative function, right? Okay, and here we will have the value 1. Okay, because even though here you have x, but you are integrating the function 0, so you will have, okay, 0 function. Okay, so which means this will be 0, this will be 0, this will be 0, and here once you integrate this, you substitute limit, you will get 1. Okay, so after we get the values or the expressions, so you transfer down the value here. So this 0, okay, and this is the region x less than 0, and here x squared over 16. Okay, so x squared over 16, we bring it down. Okay, x squared over 16, so we bring it down, and this is the region involved, 0 to 4. Okay, and then here lastly we have 1, we bring it down, and this is for the region x greater than 4. So after we get this, okay, then so this is the cumulative function. Okay, and we have one good question here coming from Bond. Okay, Bond asks, kalau combination of two functions, maka akan ada 4 region. Yes, betul Bond. Okay, kalau kita ada dua fungsi, ya, kita akan ada 4 region. So this is what we're going to discuss right after this in next example. Okay. Alright, okay, so now let's see. Okay, first how to solve this question. Okay, after we obtain the cumulative function, okay, now the question says sketch the graph. Okay, so sketch the graph of the CDF. So we just sketch now. Okay, so you can see here when x less than 0, so the function here is 0. And then because this is quadratic, right? So and the function is only defined from 0 to 4. So this will, okay, exist from 0 to 4 only. So this is 4. Okay, and when x is 4, you substitute here, y is 1. So that's why we label this as 1. And then for x greater than 4, the function is 1. So you can just extend this line. Okay, you can see that, okay, below 0, okay, the function is always 0. And above 4, the function is always 1. Because why? For cumulative function, it always begins with 0 and end with 1, yeah? Only, okay, always begins with 0 and end with 1. Okay, so now the question says calculate the probability, okay, from 2 to 3. Okay, if you want to use the PDF, you know that you're going to integrate lah, okay, from 2 to 3. Okay, because you see here, the 2 and 3 located in this region, right? 2 and 3. Okay, so if you want to use PDF, okay, if you want to use PDF, so the probability of X in between 2 and 3 is about integrating the function from 2 to 3. So you have the function, okay, define 1 over 8x just now. So 1 over 8x dx. So you will have 1 over 8 x squared over 2, 3, which means you will have 1 over 16 x squared. By substituting limit, 3 squared is 9 minus 2 squared is 4. So the answer is 5 over 16. So this is one method if you use PDF, okay, finding probability using PDF. But if you want to find probability using CDF, so this is by using CDF. We use CDF, cumulative distribution function. So what do you do? It's F3 minus F2. Why? Because, okay, you think logically, this one is 0 and, okay, the function is defined from 0 to 4. Okay, so how to get a probability 2 to 3? So we want this area, right, below this region, okay, below the graph, okay, from 2 to 3. So basically, we can obtain the F3 by simply finding the cumulative function. So this is F3. First, you accumulate, okay, you find the cumulative function, okay, the cumulative probability, which means you find the total here, F3, and then you subtract with the one that you don't want, okay, you subtract with this, F2. Then you will get this red shaded region, okay, yeah. So this is, okay, again, if I redraw, so this is F3, okay, minus with F2. Okay, so F2 means this one. So you will get the region, okay, from 2 to 3 here lah. So you'll be getting this region. Okay, because you subtract, this green represents this region. So we don't want that region, right? So we subtract, so we will be getting this region. So that's why it's F3 minus F2. Okay, so how to find the F3 and F2? Okay, very easy. If you have the CDF, okay, and you can see that the 3 and 2 are both, okay, so the 3 and 2 here are both in this interval, right? So you can substitute the value of 3 into this function, and then minus with, you substitute the value of 2 into this function. So you see here, we have 3 squared over 16 minus 2 squared over 16. Then we will have 5 over 16. Exactly similar, it's exactly equal to this answer. Okay, so these are two different methods, okay, on how can we find the probabilities using PDF or CDF. Okay, so now again coming back to the, okay, Bond's question just now. Okay, so Bond again, tadi Bond tanya kalau two function, okay, maksudnya ada 4 region, yes. Okay, so kita akan buat dalam example 2 I will show you this. Okay, so in example 2 kita ada dua function yang berbeza. Okay, now what do we do? Okay, so I would advise you, whenever you come across this continuous random variable question, you draw a number line. So draw a number line. Baru kita akan nampak jelas fungsi mana yang diwujudkan untuk region yang mana satu. So now, okay, we draw a number line and we label the respective intervals lah. So in this case, we have negative 2 until 0 and we have 0 until 2. Okay, so, okay, I'm going to use red ink here to represent, okay, the function here. So this is negative 2 until 0. The function is 3 over 16 x plus 2 squared. Okay, you notice this is quadratic function, right? Okay, then from 0 to 2, so the function involved is, okay, also quadratic, 3 over 16 x minus 2 squared. Okay, then what happens to the rest? Okay, the rest tu maksudnya what happens to this region? So this is 0 lah. And what happens to the region above 2? So the function is also 0. Okay, so now first question says find the cumulative distribution function. So again, how to find the cumulative distribution function? So first, we divide into intervals or into different regions. So now you can see here, because we have, okay, 3 numbers, so we will have 4 different regions. Okay, so if you look at this closely, so for number 1, so this is the region x less than -2. Okay, so again, okay, I write down the formula. Yeah, so I write down the formula. Okay, in order to find cumulative function, so it's the integral from -infinity until x, and we integrate the PDF. Okay, so this is formula. So this is general formula of finding CDF. Okay, so now for the first region here, so I'm going to put the x here. Okay, so that means from -infinity until x, okay, so we will have only this function. So you can see that here the value is 0. And again, this explains why the first value of cumulative function is, okay, always 1. Yeah? Again, cumulative function will always begin with 0 and end with 1. Okay? Okay. So this is the first region. Okay, so this is the first region. Sorry, yeah. Okay, you can see the function defined in 4 different intervals lah. Okay, so again, so this is first interval, this is second interval or second region, this is third region, and this is fourth region. Okay, and for the first one, we are done. Okay, now what about the second one? Okay, the second one, okay, I'm going to get rid of this. Okay, now for the second region, we are going to put the x here. In the second region here, so we put the x here. So which means from -infinity to reach this x, we will cross 2 different functions. So again, from -infinity to reach x, we will cross 2 different functions. So in this case, how to find the cumulative? So you need to split into 2. First is going to be -infinity until 2. Sorry, until -2. You integrate the 0 function, and from -2 until x here, okay, from -2 until x here, and you take the function, the quadratic function here. Okay, so it's -2 until x. Okay, so the quadratic function 3/16 x plus 2 squared dx. Okay, so you can see here it's being given here. Okay, so now for the first one, you don't really have to worry because it's about integrating 0 function, so you know that the value is going to be 0. But now when it comes to the second function here, so you just need to integrate, and the lower limit is -2 and the upper limit is x. So in order to find the function, so you just substitute x into this. Okay, and you will notice that the value here, okay, or the function is x plus 2 cubed over 16. Yeah, so now it has become a cubic function. Okay, so this is for the second region. Okay, now coming to the third region. So coming to the third region, okay, so now I'm going to get rid of this. Okay, I'm going to get rid of this x just now. Okay, coming to the third region, now we are going to put, okay, the x in the third region. So the x here, we are going to put in the third region. So you see, in order, okay, for us to find the integral from -infinity until x, it will cross over 3 different functions, right? 3 different functions means you have this first function, and then this one second function, and this one third function. This one is the third function. Yeah, you integrate until x. So that means you are going to have 3 different integrals. So first you integrate from -infinity to -2, and then -2 to 0, and then 0 to x. Again, why x? Because that is basically the formula of cumulative function. Okay, we integrate from -infinity until x. Okay, and yeah, we just bring down the respective function defined in those respective regions. So in the first region, we have 0 function. In the second region, we have this quadratic function, and in the third region, we have this quadratic function. Okay, so we just integrate, and you will have this function. Simplify it, so this is what we will be getting. Okay, all right. And then, okay, next, lastly, because we have fourth region here, so okay, now, okay, I'm going to get rid of this one first. Okay, so where do we put the x here? So for the fourth region, we put the x here. And for sure, we know it's going to be 1. Why? Okay, why? Because we know cumulative function will always begin with 0 and end with 1. Okay, so you may ask, Madam, do we have to provide all of this integral? Can't we just write down 1? Okay, so the answer is no, you still need to write down this interval. But yeah, you don't really have to show the integration. You can just keep and you just give the value to be 1. Okay, so again, this is supposed to be, okay, you can see, okay, in the fourth region. So if we put the x here, okay, so from negative infinity to reach this x, so it will cross over 4 different regions, right? Which means we are going to cross over 4 different functions. 4 different functions. So that's why we do have 4 different integrals here. Okay, so the first integral from negative infinity to negative 2. Second integral, negative 2 until 0. And then third integral, 0 to 2. And last integral is supposed to be 2 until x, yeah? So I hope you can make amendment with this. It's supposed to be 2 until x. Again, why? Because when it comes to cumulative function, it will always stop at x, okay? And we know that the value is always 1 because again, when it comes to cumulative function, it will always begin with 0 and end with 1. Okay, so after we obtain all of this, so we write down in piecewise function. Again, I need to remind you whenever you are required to find function, okay, so give in piecewise function. Again, recalling the definition, what is piecewise function? So piecewise function is a combination of 2 or more functions. Okay, all right, so this is the cumulative function, okay, of continuous random variable when we have, okay, 4 different regions, okay, or when we find or when we are given 2 PDF of continuous random variables. Okay, now we are done with the first part. Okay, now sketch the graph of PDF and CDF. So you see, this is the graph of PDF. Okay, so this is small letter f, and this is the graph of CDF. This is capital letter F. Okay, because you notice that both PDF are given in quadratic, right? Quadratic. So this is also quadratic. Okay, so I don't want to discuss about the graph sketching because okay, you should have the prior knowledge, topic 5, semester 1. Okay, and then this one is cubic here, the CDF. This one is also cubic. Okay, so okay, you just draw these respective functions. Okay, so we do have one question here. Okay, so Bon asks, Madam, do we need to write the integration steps or can we just calculate it out? Okay, maksudnya perlu tak kita tunjukkan lah. Okay, maksudnya perlu tak kita tunjukkan langkah integration ni? Ataupun boleh je terus tekan calculator? Okay, okay, my advice is the best is you show the integration. Or okay, if you notice, in previous step we have found the integral, right? So we have found the integral, which is this function. Okay, so now in order to find the value, so this is about finding the value of f0. So okay, alternatively, rather than showing integration one more time, what you can do is you just substitute the value of 0 into this function. So you see here, this is the substitution of the value into the function. So you don't have to integrate one more time. You just make full use of your answer in the previous part and you just substitute the value of 0 into that particular function, because that is about finding f0. Okay, because this is cumulative probability, right, from negative infinity until 0. So this is the function, so you can just substitute the value of 0 into this function. Okay, and you will get this one and this. But yeah, the substitution step here has to be shown. Okay, you need to show to the examiner that okay, that you substitute the value of 0 into the function. Okay, it's either one of these. You show the substitution. Okay, it's either you show substitution or okay, you need to show your integration. Okay, so which means you cannot simply skip this step. Okay, again, this step cannot be skipped. And here also you need to show, okay, how you integrate this function. Okay, so I hope that answers your question, Bon. Okay. All right, so now let's continue. Okay, after we obtain the graph, then find probability x greater than 1. Okay, so probability x greater than 1. Okay, so this is the use of the, okay, we find, this is finding probability from PDF. Sorry, this is find probability from CDF. Okay, find probability from CDF. You can see here. Okay, if you draw again number line. Okay, so the function is defined from negative 2, 0, negative 2, 0, and 2, right? Okay, so now they want to find the probability of x greater than 1. So you can see that x equal 1 is located here. Okay, x greater 1 is located here. So you want to find probability x greater than 1. So, okay, using the CDF, you can just subtract the rest here lah. So it's about, okay, subtracting this F1. Okay, so it's 1 minus F1, so you will be able to obtain this region. So this is the region that we want. So this is the region that we want. And the gray area here is the region that we don't want. So that is why you may see here, okay, it's 1 minus F1. Why? Because F1 is the one that we don't want. So how can we find F1? Okay, you will see that here in this CDF, 1 is located here, right? Correct or not? So in order to find F1, you substitute the value of 1 into this function. Okay, so you will see that here we substitute 1 into this function. Okay, so this is the substitution step, yeah? 1 minus 2 cube divided by 16 plus 1. So this is the value of F1, and then you put 1 minus, so this is 1 over 16. Or, okay, if you want to use, okay, if you want to find the probability, okay, from PDF, okay, so you may see that probability of x greater than 1 is equal to integrating. Okay, so this is 1, right? So integrating from 1 to 2. So you will have the integral 1 to 2, and you integrate the respective function. So as you can see from the question, the function here is defined as 3 over 16 x minus 2 squared. 3 over 16 x minus 2 squared dx. So integrating the function 3 over 16, so you will have x minus 2 cube over 3. 1, 2. Okay, so here you can cancel this one out, so you have 1 over 16. So you will have 2 minus 2 cube minus with, okay, 1 minus 2 cube. So you will have 0 minus negative 1, which is 0 plus 1. So the answer would be 1 over 16, exactly equal to this one. Okay, so I hope you can see the difference, yeah? Finding PDF, okay, sorry, finding probability from PDF, and here finding probability from CDF. So I think you may find this, the first method here is easier. Why? Because if you find probability from CDF, it's about substituting the value. Okay, this is about substitution. Okay, you just substitute the value of x into the respective CDF, and then you can obtain the probability. But now, if you need to find probability from PDF, it's about integration. You need to show the integration. Why? Because it's about finding the area, right? So you need to show this integration step. Okay? Alright, so any questions so far? Okay, so I hope you now, by this time, you really, okay, you can now get some of the concepts, okay, if not all. Okay, so at least you can grab some of the concepts of, okay, continuous and variable. So again, okay, let's recall what we had discussed today. Okay, this is the summary. Okay, so again, let's recall what we had discussed today. Okay, so for continuous random variable, okay, so we know that, okay, the representation of PDF probability density function is represented by this small letter f. Okay, all right, and then how to show that it is a continuous random variable? So by showing that total area, so total area below the graph. Okay, so total area below the graph should to be 1. Okay, and then in order to find the cumulative function, okay, we use this formula. Okay, and then in order to find probability using CDF, okay, so you just use this formula. And okay, you can see here for continuous random variable, the equal sign does not matter because they actually, okay, give you the same meaning. Why? Because they actually give you the same probability. So this is the region probability of X in between A and B. Okay, so which means this is actually the area of the graph from A, okay, the area below the graph from A to B. So this is basically, okay, these are all actually the same thing. Okay, so which is the area below the graph from A to B. And then how to transform, okay, so from PDF to get CDF, you just need to integrate. And tomorrow, not tomorrow, okay, next lecture, this Friday, we will discuss on how to find PDF from CDF by differentiating. Okay, so again, you need to know the concept of differentiation. Okay, and we will discuss also the following here in the next lecture. Okay, and here in order to find mode, okay, by hook or by crook, you need to sketch the graph and you just find the highest peak. Okay, and yeah, we have also one question here. Okay, coming from audience. Okay, so Phil says, until what number tutorial, madam? So if you can refer the tutorial question, okay, number 2 until 13. Okay, so number tutorial question 2 until 13 involves discrete random variable. Okay, so now when it comes to continuous random variable, tutorial question number 14. Okay, number 14 until 22. It's about continuous. But okay, based on our lecture progress today, okay, you just skip any question asking you to find the expectation because we haven't discussed yet. Expectation, variance. You may skip first because we haven't discussed this. Okay, but you can do any question asking you to find probability. Okay, kalau soalan minta probability ke, soalan minta finding CDF ke, okay, so you can try to solve the problem. Okay, or finding the mode. Okay, so you can try, okay, to solve the questions. Okay, so I assume that this 1 hour is enough for us to discuss this continuous random variable. Okay, so I hope you can try to recall, okay, and or try to do some of the problems, okay, so that you can see the application of, okay, the concepts that we had discussed just now. Okay, so all right, okay, no problem, Frizana. Okay, so I think that is all for today. So thank you for your thank you for your presence, and thank you for your attention. Okay, so if you need help, then okay, you can try. Okay, you can consult me. Okay, we may discuss in the Telegram group. Okay, so that's all, guys, for today. So okay, I end this lecture with Assalamualaikum warahmatullahi wabarakatuh and have a nice day. Okay, my pleasure, Aisha Uthman, Aisha Adnan. No problem, Nurin. Okay, Assalamualaikum.